Here we have a very typical Pythagorean theorem problem. We're given the following information and we're asked to find a hypotenuse of a right triangle. So it says, what is the length of the hypotenuse of a right triangle with legs of 9 inches and 40 inches? I don't know. Let's figure it out. I do know that a squared, one leg, plus b squared, another leg, is going to equal c squared, the hypotenuse. So the leg length I was given was 9 to the second power. That's what I need to do to it. Plus 40 to the second power will equal the hypotenuse to the second power. And I want to find the length of the hypotenuse. All right, so 9 to the second power is 81, and 40 to the second power is 1600, and that would equal c to the second power. Combining 1600 and 81, I would get 1681 equals c squared. All right, at this point, you may recall this from earlier in the course, I'm going to take the square root of both sides. And the reason I'm doing that is because I want to solve for c. The square root of c squared, of course, is c, and the square root of 1681 is 41. And so the length of that side is 41 inches. Here's another example of a Pythagorean theorem problem. Here we're given an image of a right triangle, and we're asked to find the hypotenuse. And once again, I always like to start with my formula. And for my legs, I have 6 squared, by the way, plus 11 squared is going to equal c squared. And yes, you should be using a calculator here. And of course, this would be 36 plus 121 would equal c to the second power, or c squared. And I'm going to slide this up a little so we have enough room for our calculations. Sorry about that, folks. And this, of course, would equal 157. That would equal c squared. And taking the square root of both of these, and I would find out, I'm just going to continue right here, that this would be, c would be approximately rounded to the nearest tenth, which is what I was asked to do, 12.5 yards. And that is how we solve that problem.